The solubility calculation. So this is the equation. 90.0 gram of MgCl2 was placed in 50.0 cm cube water to give a saturated solution of 98 Kelvin. If the solubility of the salt is 8.0 mol per dm cube at the same temperature, what is the mass of the salt left undissolved at the given temperature? So these are the options. Now, let's interpret the question. This is the mass of the solid that is dissolving in water. So the mass of the solid is given to the 90.0. Mass of water, which is also called the volume of solution, is 50.0 cm cube. So the solubility is here at 90 degrees, at that particular temperature is given. So we are going to use this formula. Solubility in mol per dm cube is equal to mass of dissolved salt or solid over relative molecular mass as 1000 over volume of solution. So you first calculate your molar mass, relative molecular mass. We have done that. See, Cl2, Cl is 35.5 multiplied by 2. So that is what you did here, plus 24 for Mg. Then you get 98. Then let's take the formula. We want to interpret, we want to put in, let's slot in those values into the formula. Solubility, we have 8.0. Mass of dissolved salt is not given. So we put X in that position. 98, we have gotten the relative molecular mass. The volume of solution is 50. Then when we multiply X times by 1000, we get 1000 X. This times this one, we get this. So when you cross multiply, when you divide by 1000, you get this. Then that is 38. 38 is the mass, 38 gram is the mass of dissolved solid. But the question asks you for mass of the undissolved. Then you are going to use this illustration. Mass of solid consists of what? Both the dissolved and the undissolved. So in the question you are given 90 as the total mass of the solid. So the one we have gotten is the dissolved plus the undissolved. So you make undissolved solve your formula. At the end of the day, you get 52. Yeah, let's go to back to the option. So which of them is 52? So A is the answer. So we can see this under question UTME 2010, number 15. Calculate the solubility in mol per dm cube of 40 gram of CuSO4 dissolved in 100 gram of water at 120 degrees Celsius. So we have option A to D. Now, let us highlight, bring out the parameters in the equation. Solubility in mol per dm cube, that's what we are looking for. Unknown. Mass of dissolved solute is given. See, mass of water. Check. The mass of water, this is the same thing as the volume of solution, which is what? 100 cm cube. So we use this formula, so solubility in mol per dm cube is equal to that and that. Then let's plug in all the parameters. So, but we have to calculate the relative molecular mass, which is the molar mass without units. So CuSO4, you are given everything you have to use, the relative atomic mass of individual elements present in that compound. So 64 plus 32 sulfur, then 4 times 16, everything will give us 160. So at the end of the day, coming back to the formula, this we have 40 over 160, mass of the solute 40, relative molecular mass 160, then times 1000 over volume of solution. Volume of solution is 100. So you get this. And the right option is A. Thank you. Solubility product. So that is another, I want to calculate anything question based on solubility product. So we have this. So now we differentiate into Ag plus and Cl minus. So the term solubility product means that we are only dealing with the products. You understand? Now, what does KSP means? Constant of solubility product. So we can express this one in this form. KSP is equal to this and this. You understand? Please always make sure you put the square bracket put the square bracket. Now, let's have an example. What is the KSP of a code? Okay, I'm coming. I'll answer the question. What is the solution of a code? What is the KSP of a code of this molar? That's a mole per dm cube of AgCl. So let's dissociate that. Then use this formula. So we are going to take this one for individual species. So you use this one to multiply for this one and this one. So when you multiply, so we get this. But take note of the unit. The unit is mole times mole, that is mole square, dm cube times dm square. So that is that one. So let's go to example number 2. Let's go to example number 2. We have number 2 example. Given that the KSP for NaCl is that at that temperature, calculate the solubility of NaCl in water at that temperature. Now, we are going to take the salt, then we dissociate, we get this. So, but take note that we are given the KSP, so we are looking for the solubility of NaCl in water. So, whenever NaCl whenever you put water into NaCl, what will happen is that it ionizes. You understand? What does it mean by ionization? It splits into the positive and the negative ion. So that is what we need for the KSP, and this is expressed this way. So we take the value given to us for KSP, we put it there, then x times x, so which is x squared. At the end of the day, you take the square root of both sides, then we are going to get this answer. So this is another question on solubility product. So we have the solubility product of calcium bromide, which is CaBr2 at 25 degrees Celsius. Is this? Calculate the solubility of the solute in mole per dm cube and in gram per dm cube. Now, let's dissociate the salt given to us. So it will produce this and this. Please take note that calcium ion is x and bromide ion is 2x because of these two in front. So now let's go to the solubility product. So we use this expression for the solubility product. Then the KSP x, we are going to take the value of our ion as in when we dissociate it. So you take this one as x, you take this one as 2x. Then we are going to take the power, if there is power, for the solubility product expression. So that is where you see this one. Then, having done that, you get 4s cubed. Then, the solubility product was given to be this. See, you can see, the solubility product is this. So, now, after doing that, you use your mathematics, you get this one. Then, cube root, you find the cube root, then you get this one. This is x value. Then, x value is the solubility of the solute in mole per dm cube. So that is good. So let's go to gram per dm cube. This is the expression for the number 2. So we are going to get, so there's a connection between mole per dm cube and gram per dm cube. This is the expression. Then you make the gram per dm cube is something of formula. So you get this. Then let's calculate the molar mass of this one. So we have 40 plus bromine is 80 times 2, that is 160 plus 40, giving us 200. Molar mass is gram per mole. So at the end of the day, we are going to multiply these two and we arrive at 1.44 gram per dm cube. So that is the solution to that problem. Thank you. Okay, that's the question. That's another question on solubility product. Solubility product of Cu into bracket I with K plus bracket 2 is that, assuming that neither ion react applicatively with water to form H plus and OH minus for the solubility of the salt. Okay, let's go to the solution. Let's go to the solution. We have the solution here. So, since it is water that is reacting with it, water will dissociate this to this and this. So look at it. We're going to dissociate into that and that. Now, please, you take this first one. It's going to be equal to x. This one too will be equal to 2x because there is a 2 as mole in front. So now let's find the solubility product. So this KSP will give us this and this. So these two in front is this power here. You know, according to equilibrium constant, we always have that kind of, but this time around we are talking about solubility product. So we are only dealing with the product. So and the product has 2. It's going to be raised to power 2. Then this one, we are going to take x, since this one is equal to x, but we are still taking the bracket. Then this one, raised to power 2. This one is here, so raised to power this 2. So we're going to have, please, 2. This one is 2 raised to power 2, and this one is also x raised to power 2. So the analysis is here. So the analysis of this one is this one. So if I multiply this one and this one together, it will give me this, which is what? 4x cubed. You understand? Now, the 4x cubed is written here, so it's equal to the KSP. So KSP is this. So that's why I put it in here. So in the question, please, it's given in the question if you want to know. Then at the end of the day, you divide both sides by 4 in order to make 4 leave this side. So we have this given as this. Then you find the cube root and you have the final answer like that. Please, you can drop your comments